All right, welcome everybody. Today we're going to talk about lesson number 75. This is still section 10.2. We're going to talk a little bit more about the parabola, and then we're going to start talking about circles. Now, circles are probably the conic that you're the most familiar with, most likely from your geometry days. Please note that in your homework tonight, it does not include any circle problems because circles are most directly related to the ellipse conic, which is what we're going to see next time. So we'll save the circles for then. Please note that if you do want to review anything about circles, you can do so at any time in section 1.2 in your book. And then that Desmos link is still the parabola link, since that's what we're spending the majority of today's lesson on. So continue to visit that site if you want to see directly how each of the different variables affects the shape. So just a little bit of a reminder about what it actually means to be a conic. Remember that a conic is the intersection of a plane and a double napped cone. These are, again, the four conics that can result. We've already talked one full day about the parabola. So now we're going to talk a second day about the parabola, and then we're going to start talking also about circles. A reminder about the equations for a parabola, a reminder that there are technically four different versions. These first two versions are what you would use if your vertex is anything other than the origin. Remember that the h always comes from the x term and the k always comes from the y term. These two problems down here, or rather these two formulas, those are the simpler versions, and those are the ones that you would always use if the origin is 0, 0. A reminder about the four different possibilities. So here you have parabolas that face up or down. You know that the parabola will face up or down if the x is the thing that is squared. You'll know that it faces up if p is positive. You'll know that it faces down if p is negative. Then, of course, a reminder that p is always the distance from the focus to the vertex and from the vertex to the directrix. Generally speaking, the larger p is, positive or negative, the wider it's going to be. But remember, since we're just sketching, we're really not too concerned with the width. Your other two options, of course, if the y is the quantity that is squared, you know that it's going to be left or right. If you have a positive p, you're going to the right. If you have a negative p, you're going to the left. So in these 9 next examples, they're all asking you to find the standard form of the equation of the parabola with the given characteristics. So this should actually be easier than the lesson from yesterday. Please note that the only thing that you would be given as the problem is the values inside of this box. You yourself would have to create the graph, and you would have to decide which form of the equation to use. I've simply added them in ahead of time just to save time. So if the vertex was 0, 0 and the focus was 2, 0, again, given the fact that I'm just trying to save time, the vertex would be the first point and the focus would be the second point to the right of it. Once you take the information and translate it to a graph, you would easily be able to see the value of p. Remember, the value of p is the distance from the vertex to the focus. And because the graph is opening to the right, you know that p has to be positive. And in this case, it has to be exactly positive 2, because that's the distance from the vertex to the focus. Once you know that p is equal to 2, you're going to go ahead and take a look at your formula. Notice that I have chosen the y squared formula because the graph is facing to the right. And notice that I have chosen the simpler version because of the fact that the vertex is 0, 0. So all I have to do to finish this problem is plug in the value of p, which again I figured out was 2. So y squared is equal to, if you plug a 2 in for p times 4, you get y squared is equal to 8x. Here in example number 2, again, I've drawn the graph and put the equation in ahead of time just to save time. You yourself will have to make the graph and decide what equation as you go to complete the homework problems. So in this case, the vertex is actually to the right of the focus. So again, I'm trying to figure out what p is. P is the distance from the vertex to the focus, but it has to be directional. So because you're traveling to the left from the vertex to the focus, that's why p in this case would be -2, because you're facing in the negative direction. Notice that the equation that I chose the y being squared because it's facing to the left, and I chose the more difficult version because of the fact that the vertex was not at the origin. So in order to find my answer, not only do I have to plug in the appropriate p value, but I have to also plug in the appropriate values of h and k. So y minus k squared, that is going to become y minus 2 squared. 4 times -2 is -8, x minus 3. And when they say standard form of the equation, this is exactly what you want. You don't want to square anything. You don't want to multiply. So this is going to go ahead and be your final answer. Here in number 3, again, you have the vertex, which would be 2, 1. And then you have the focus, which would be on top of the vertex in the positive y direction. Because it's in the positive y direction, that's how you know that it would be a positive value. And if you counted exactly how many spaces it was from 2, 1 to 2, 4, that's how you could deduce that p was equal to positive 3. Choose the version of the equation that has an hk and that has the x being squared. So as I go to plug in my answers here, x minus h squared, that is going to give me x minus 2 squared equals, plug in p, 12, y minus 1. As we proceed, if you're thinking that you understand it, again, maybe pause and try it, but let's just do a couple more to make sure. So the vertex is 0, 0, and in this case, they give you the directrix being y equals 3. So if you knew that the vertex was 0, 0, and you knew that the directrix was y equals 3, you could also figure out the focus because you have to go the same distance from the vertex to the directrix as you have to do from the vertex to the focus. Either way, the graph would wind up looking like this. Remember that P has to be directional. So because the graph is facing down, you know that P has to be negative. And in this case, it has to be negative 3. Simpler version of the equation because the vertex is at 0, 0. So plug in your value of P gives you negative 12 times y. Example 5, vertex 0, 0, directrix x equals negative 3. So this is where you have to make sure you know that x equals is always a vertical line and y equals is always a horizontal line. The distance between the directrix and the vertex, remember that's always p and it's always directional. So because it's facing the positive direction, you know that p is equal to 3. Simpler version because the vertex is 0, 0. So I get simply that y squared is equal to 12x. Here, the vertex is negative 2, 1, and the directrix is x equals 1. So again, you're trying to figure out what p is. Because of the fact that p is facing the left way is how you know that p has to be negative. You're going to go ahead and find the distance from negative 2, 1 to the directrix at x equals 1. So that x distance from negative 2 to 1 is 3. And again, it's negative because of the direction. Notice I have the more complicated version because of that vertex. When you go to do the equation, just make sure that you're always putting the h with the x and the k with the y. So I'm going to wind up with y minus 1 squared. Plug in the p gives you negative 12. And then x minus a minus, of course, becomes x plus 2. And again, please don't distribute or multiply anything out. This is considered to be the standard form of a parabola. Even if you're skipping ahead, don't skip 8 and 9 because those are a little bit different. Here in number 7, okay, so here is, a little bit slightly different because of the fact that they give you the focus and the directrix. You have to be careful because the distance from the focus to the directrix is actually 2p. You have to find out p, which is just the difference from the vertex to one of those. So if you take a look at this, you can see that the distance from the focus to the directrix is actually 2. That means that the distance halfway would be how you get to the vertex, which would be 1. And again, because of the fact that it has to be directional, it's facing to the left, that's how you know that p would be negative 1. As you go to plug in your values here, notice you actually have to figure out what the vertex is. So the vertex has to be exactly halfway between the focus and the directrix. So the vertex would be 1, negative 2. You're going to need that for your equation. So y minus negative 2, of course, becomes y plus 2. Don't forget to square it. Plug in your p, gives you negative 4, and then x minus 1. And again, make sure that you're using those vertex values to find your h and k. Don't get them confused with the focus or the directrix. Basically, as hard as it would get would be something like 8 and 9. Notice that in 8 and 9, you can clearly see where the vertex is, but you don't have the focus and you don't have the directrix. So looking at this problem right here, you can clearly see that the vertex is at the origin, 0, 0. That's how I know to choose the simpler version of the equation. And I chose the y squared version because of the fact that it's facing to the left. If I don't know the focus and I don't know the directrix, I'm still trying to find p. And the only other way that I can do that is by using a point on the graph, preferably the big one that's stated for you. Yes, you could try to estimate other points, but please don't make things difficult. If you're trying to use an additional point on the graph, that is going to be your point xy, because of the fact that your vertex always has to be hk, always, always. And again, I don't even have an hk in this formula because I chose the more complicated one. So I still need to solve for p. That is what I need in order to find the equation. So using my equation and using the point, -2, 6, I am going to plug 6 in for y. For p, I'm going to plug -2 in for x. That is going to give me 36 equals -8p. If you then divide by -8, you're going to get p equals 36 over -8, which is -4.5. So once I know p, that's really all I need. So y squared is equal to -4.5 times 4 is -18x. Last one like that. So again, find the standard form of the equation using the characteristics. Please note here that 3, -3, that is the vertex, which means that has to be h and k. You don't know the focus, you don't know the directrix. Your mission is always to find p. So you're going to have to take this point, 0, 0 in this case, and that is going to be your xy. Be careful, you're not always making 0, 0 hk. You have to look at the graph and assign the variables accordingly. So similar to the previous problem, except now you have more things to plug in. So, as you go to plug in, you're going to plug in 0 minus 3 squared equals 4p, 0 plus 3 minus a negative. Okay, so 0 minus 3 is -3 squared is 9 equals 12p. That's going to tell you that p is equal to 9 over 12, which is 0.75. So if p is equal to 0.75, your final equation here, leave the x and x, put in the minus h, don't forget to square it, 0.75 times 4, that is going to give you 3, and then y plus 3. So again, don't square it, don't multiply it. That is exactly what you're looking for. So those 9 examples are kind of the crux of today's lesson, but we're also going to talk about circles. Circles are probably what you're the most familiar with, and they actually lead right into tomorrow's lesson, which is about ellipses, but I didn't want to put them with the ellipse lesson or else it would be too long. So first of all the circle problems in your book, for the most part, are actually in section 1.2. So I'm not assigning you any circle problems tonight because when you do the ellipse homework tomorrow, you're going to get the practice in there. But again, I just wanted to split the lessons up in the most time-efficient way. So a reminder that a circle is the set of all points in a plane that are distance r from a given point called the center. And the distance r is, of course, the radius of the circle. So over here, you have a little visual. And then you have 2 versions of the equation, one of which, again, is the simpler one if the center is at the origin, one which is a more complicated version if the center is at hk. And again, you're always going to do the opposite, and the h is always going to go with the x, and the k is always going to go with the y. Biggest mistake people make is they forget to do r squared, so try not to do that. And again, finally, in order for this to be considered standard form, you can only have a coefficient of 1 in front of the squared. So make sure that if you don't have a 1 in front of the squared, you divide before you try to make any conclusions about what the radius is. So some simple problems to start: find the center and radius of each circle and then graph it. So here, the center is going to be h, k, and remember the h always comes from the x term, the k always comes from the y term, and you're always doing the opposite. So your center is going to be 3, -7. This value here is always going to be r squared. So your r in this case is going to be the square root of 19. The square root of 19 cannot be simplified, but it is equal to approximately 4.4. And really the only reason why you would care about that is because if you go to graph it, so if you're going to go to graph this, you're going to go to the center, which would be 3, -7. You would count approximately 4.4 in all directions. And then, again, you would go ahead and sketch it. And again, yours should be a little bit more precise than mine. It's a little hard for me to draw the dots, so I'm sure you understand. Okay, 5x squared plus 5y squared equals 45. Think back to what I said a few slides ago. Before you can make any determinations about anything, you have to make sure that there are only ones in front of the square terms. So you would first have to divide by 5 to get x squared plus y squared is equal to 9. Because of the fact that it's a circle, you have to have the same coefficients in front of each square term. If they were not the same, that's what makes an ellipse. And again, that's tomorrow. So once you're down to here, you can now conclude that the center of the circle is at the origin. You can conclude that the radius is equal to the square root of 9, which in this case would be 3. And again, how would you graph this? Well, you would start with the origin being your center. You would count 3 in all directions, and then you would graph. And again, yours should really be even more precise than mine. Here in number 3, I don't have any division to do, but I don't like the way that this looks because I don't want the square terms to be on opposite sides. So I'm going to add the y minus 1 squared over to give me this. Once I'm here, I can declare that the center of the circle is equal to 0, 1. I can find that the radius of the circle is equal to 10. And again, I think you get the idea of how you would best graph that. Really, the only way that it might get difficult is what if it is not in the standard form of the equation? So again, I remind you of how you complete the square. This is the same reminder slide as yesterday. So your mission is to first get all the x terms on one side and then the constant on the other. You take half of the b term, square it, add it to both sides, and then rewrite it as a quantity squared. So take a look here at number 4. Again, it's a similar problem, except for the fact that it is not written in the format that we want. So we are going to have to do some completing the square. The first thing you should notice is that the x squared is by itself and there are no x terms. So that is good to go. It's the y's that I have to worry about here. So leave the x squared. He's perfectly fine. Then y squared plus 12y. Leave a little space. 0 on the other side. I'm going to have to complete the square for the y's only because I need to write it as a quantity squared if I'm going to be able to figure out where the center is. So take a look at positive 12. Half of 12 is 6. Squared is 36. You have to add that 36 to both sides. The whole point of doing this is that you can now take this entire y squared plus 12y plus 36, and you can write that as a quantity squared. It's always whatever the variable is, and then it's always whatever half of the middle term was. So remember, half of 12 was 6. Now you can declare that the center is 0, negative 6. The radius is the square root of 36, which is 6. And again, I am supremely confident that you could go ahead and graph that. Number 5, again, maybe pause and try it if you're feeling good. Notice here that we have x terms, and those x terms are going to need a completing the square, so you should put those together, and then you should leave a little space. Then I'm going to take the y terms, and I'm going to put those together, and I'm going to leave a little space, and I'm going to move the constant to the other side. So in this case, I actually have to complete both the squares, one for the x and one for the y. Looking at the x's, half of negative 6 is negative 3, squared is 9. I have to be sure to add 9 to both sides. For the y values, half of positive 4 is 2, squared is 4. And again, I have to make sure that I add that to both sides. Looking at my x's, that's going to become x minus 3 squared. Looking at my y's, that's going to become y plus 2 squared. And over on the other side, if I add up all those constants, I get a value of 25. That makes life very easy and simple. So the center is going to be equal to 3, negative 2. And the radius is going to be equal to the square root of 25, which is 5. And again, graph it if it says. I assume you could certainly do that part. Last but not least, given some values, please go ahead and write the equation of the circle. So if I know that the center is not the origin, that's how I know I'm using the more complicated version. As I go to make my equation, I'm going to do x minus h. Don't forget to square it. Y minus 3. Don't forget to square it. And then again, the most common mistake people make, don't forget to actually square the radius for the other side. And please don't multiply anything out. This is the form that you want. This is considered to be the standard form. The center 6, 0, and the radius, the square root of 15. So that's going to give me x minus 6 squared. Because of the fact that k is 0, I'm just going to get a y squared. And then if you square the square root of 15, you just get regular 15. And last but not least, the only way that could get more complicated is what if you did not know the radius and instead you had the center and you had some point? Well, again, similar to what we did for the parabola, your center is always going to be hk. If you have some other point, that always has to be xy. So plug the values in accordingly. So x is 5 minus 2 squared plus y is 6 minus 3 squared is equal to r squared. 5 minus 2 is 3 squared is 9. Another 9 equals 18. So 18 is going to be equal to r squared. And again, because the equation is r squared, that's what you want. In your final answer, you want to leave the x in x and then put in the appropriate h. Don't forget to square it. You want to leave the y a y, put in the appropriate k, don't forget to square it, and then this is going to be equal to 18. And again, it's equal to 18 because you want it to be equal to r squared.